And now it's time for the final session of today, which is by Google. It's a sponsored session. But as you know, the sponsored sessions are always high quality at DevDays. And this, hi, Vivian. Welcome on stage again. No one's leaving. No one's leaving. So this talk is, I'm very curious to learn what it's about, but this is how Alphabet, so not Google, but Alphabet solved their interoperability problem across the organization. You would say Google, they have it all okay. Not so much. You do. Okay, you do now, thanks to FHIR, right? Okay, so here you go, Vivian. Good luck.
All right. Hi, everyone. Thank you so much for staying. I know I'm like completely forcing that one, and I'm about to photobomb that picture over there after this. But while we get this set up, I'm Vivian Neely. I'm one of the product managers at Google, and actually, yes. And I'm actually going to invite a few other people up who are over there. If you all want to wave your hands, and I'll have them do introductions, as each individual's talk. But one of the things that we are, let's see, let me make sure I do this correctly. So someone gave me the opportunity to come and actually do the session. So someone above me said, we're going to sponsor DevDays. And I'm pretty sure I was the only email that they had. And so they said, Viv, go do the sponsored session. And I was like, great, I got 30 minutes to talk about whatever I want. What do people not know about Google? What are the things that people do not understand about how Google's using FHIR, about Google in general? The only thing that came to mind was the org chart. I joke you not, I was like, I have a slide of 8 of us, but there are actually, so there's 5 of us on the slide. There's actually 8 different organizations under Alphabet who all use FHIR. And I had this moment of like, that's kind of cool. I don't know, it seems like people might care about that. We're at FHIR DevDays. But did we solve anything by 8 other organizations using FHIR? And so I took this deep dive into, it actually had a round table where I said, hey, everybody, tell me all the things you know, because I have to go tell everybody else. And so we had a FHIR roundtable. There was like 200 people there. We got everyone together to talk about all the things that they do in FHIR. I'm about to botch 4 other organizations' use of FHIR. So I'm going to apologize in advance, other than Jing, who I asked him to please do his organization because he was here. But verily, Fitbit, apologize in advance. No, I think that this is actually a really cool introduction. So the first thing that we talked about was we have this team called FHIR Foundations. I just had a really good conversation with Chris Grenz where he's like, they don't get enough respect. I think nobody actually realizes that we have a whole team of people who wrote our protos. Now, these are available on GitHub. You can build your own validator using the protos that are available using Google's, I think it's Google/FHIR. And so there's actually a whole team of people that their job is to know and build the protos that the rest of what I would consider probably 1,000 engineers across Alphabet are building enterprise products off of. So that's pretty cool. So we have a whole team of people building protos, validators, basically all the things that you would see on the open source. Now, the nice thing about this is, there's not that, if we keep versioning ourselves, there will be enough work to go around. But at some point they got bored and they said, well, I don't think anyone's using our protos. And I was like, well, that's because nobody has FHIR data at this point. This is maybe 5 years ago. And they said, all right, well, we can fix that. I think we were still on S2, 3, R4 was a bit away. We had time. So I said, all right, we can fix that. We went and asked a bunch of people, and this is out of the research organization, so they had time, money, energy, all the things that my cloud, enterprise cloud is not as friendly about. But the research organization went and polled a bunch of people and said, if you were going to map your data to FHIR, who would do it? And the answer was almost entirely informaticists. And we talk a lot about the people who don't feel at home at FHIR DevDays. And I always think back to that moment where the people who know, and I used to work at a small organization that did exactly this. The people who know exactly what a blood pressure is are not the people that are building the applications. They're the informaticists, they're the clinicians. There's an overlap. I think, what we're seeing more and more technical skills being kind of brought into those kind of common workflow or common career paths. But a lot of people said, no, it was the people who use UIs. And so this team went and built an awesome UI to do data mapping. Now, this is not available. I got permission to show a preview product. It will be available. So we are releasing a UI to do data mapping to FHIR for the non-technical users, which if people know me, they know I'm very passionate about the non-technical users of FHIR because they're often also women. So shout out to the Women for FHIR. So this team also was able to actually build, and let's see, it also came out that this team was going to go ahead and build what we know as SQL on FHIR. So SQL on FHIR was from Ryan Brush. It was a while ago. There's a bunch of work happening now where everyone said, wow, have you ever tried to query SQL on FHIR? And everyone was like, no one queries SQL on FHIR. Like it is nested arrays. And back to the moment where we said, most of our users are going to be UI based. We then gave them a SQL database that was like 1,000 columns of arrays. And they were like, yeah, we're not going to do that either. And we were like, all right, we'll figure this out. That birthed the analytics working group, or the SQL on FHIR analytics working group. And so they're doing great work to figure out how we can better FHIR views in a tabular relational database. Lots of actually active Zulip chat. And I see Nikolai sitting here somewhere. If you have conversations, questions about that, he's here in the room that can help answer. So Cloud took that and said, all right, someone asked us to make money. They said, Viv, go do this thing. So we had to go take those protos and do something with them. What we did is we basically built a managed server. This means that we take care of the infrastructure. You don't have to think about any of the scalability, what type of operating system you're using, what networking you're using. We basically operate right in the middle between what you would think of as a traditional virtual machine and what you would actually think of as workspace. So the classic software as a service. We're right in the managed service. We have 3 modalities. We have lots of functionality within these modalities. So import, export, notifications, all the kind of traditional CRUD search. We also have define your own search. I would consider us a comparable, FHIR server to a lot of the people that probably develop and work on FHIR today, as well as if I will put these slides out and we have kind of a full GA capabilities list available as well. I will put these on Hoover. I think they're not there right now. I will do so. And so Cloud went ahead and built a managed offering for FHIR. And then what then happened is Verily said, that's kind of cool. We don't want to do infrastructure. We are really close to research and to individual organizations and to individual users. So Verily went and built, actually, I think they have 3 applications. And again, I'm going to probably give them no justice, but they went and built individual applications for end users, which is really not what the foundations team, nor research, nor Cloud is meant to do. They're very business to business. Verily went and did a bunch of consumer applications using our products, which is great because what ended up happening is now Alphabet has a bunch of users of both Cloud and foundations that give feedback. So before you guys find our bugs, Verily probably already filed it. And that's great for you because that means that we'll fix bugs a lot faster than you have to see the bugs. And I think that's something that's really cool about what the Alphabet ecosystem has developed. I don't have a slide here for Fitbit, but I will give them a shout out because they're actually now working a lot harder to move kind of and integrate their data into the healthcare API. Now, this is the great part where I don't have to talk and you don't have to listen to me. I'm going to invite Jing up here. He is, I'm not going to introduce him because I'm going to do the complete wrong one, but he's actually doing a lot of our open source work with Android. And so he's going to talk a little bit about all.
Thanks, Vivian. I struggle to talk about my own project. I don't know how you do that for other projects. So very impressive. Thanks everyone for having me. My name is Jing. I'm a software engineer at Google. I work in Open Health Stack. And I'm going to talk about Open Health Stack next. So here with me today at DevDays is also FHIR. I think you may have been to his talk on data analytics earlier today and his Let's Build session. So the two of us here representing Open Health Stack. How does this work? There we go. So Open Health Stack, we focus on global health. And there's some scary numbers and big problems to solve in global health. 52% of people don't have access to essential healthcare services. That leads to 9 million preventable deaths every year. And this is obviously mostly impacting low resource communities the most. This is also exacerbated by the problem of growing shortage of healthcare workers, which is estimated at 30 million at 2030 by data from the World Health Organization. So here's some really big problems. And digital health solutions have actually been traditionally seen as a tool to close these gaps, but it hasn't really fully delivered on the promise due to a number of challenges. For example, there's the lack of use of standards that results in public health programs doing their own thing, having their own data model, creating data silos so they can't talk to each other and the data can't be reused. There is this problem of evidence-based guidelines being very difficult to be translated into practice, right? So that results in poor quality of care as well. And then poor design and poor usability limits the success of these programs. So with these challenges in mind, what is our mission? So as a team, our mission is to help developers to create next generation health solutions to close that equity gap in public health. We want our solutions, so by next generation, what we mean is the solutions should be patient-centric, should be interoperable, should be data-driven, which means they need to incorporate clinical decision support. And with that, we hope that creates a marketplace for innovation, which means developers will have the basic foundations laid out by Open Health Stack, and they can focus on the advanced capabilities and put those capabilities into the hands of the health workers. So a bit more concretely, what we do, we create the building blocks. We want developers to use our building blocks to build their own healthcare solutions. So these building blocks are open source, and they can build with the Open Health Stack components, their healthcare solutions faster, and then they can also focus on security, privacy, interoperability, and all the good stuff that comes with it. And one note is that we create these building blocks with low resource settings in mind. For example, Android FHIR SDK, which is my project, is a set of tools that help you create Android apps that can work offline. And that is very, very important in a lot of the low resource settings where you don't have data access. Just to illustrate the problem a little bit further. Sorry, there's a lag. Oh, right. This is the right slide. Just to illustrate the problem a little bit further, we see that when building healthcare solutions, there's actually a lot of hidden complexity. It's not just the app that you see, it's the data interoperability layer that's behind it, is the authentication, authorization. There's a lot of hard stuff that people have to solve. And the whole purpose of Open Health Stack is to, take away some of that complexity and solve some of that for you, so you can focus on innovation. This is an architecture diagram that's in a bit more detail. So at the bottom, we have listed out the components of Open Health Stack together with some storage options. And on top is the sort of implementation layer that developers can create using the Open Health Stack components. So just really quickly to go through some of them, Android FHIR SDK, as I mentioned, is a set of Android libraries for you to create Android apps using FHIR. It has 4 libraries. There's the FHIR engine that stores data and syncs data with the FHIR server. There's the SDC library that handles data collection on Android. There's a workflow library that handles CQL and clinical decision support. And there's a knowledge manager library that stores IGs and knowledge artifacts on Android. So FHIR Info Gateway is this access proxy that can sit in front of any FHIR server that handles authentication and authorization for you. So making your architecture more flexible and more modular. FHIR Data Pipes, that's the project Bashir talked about today. It's a set of tools that allows you to do horizontally scalable analytics. So you transform data from FHIR to a data warehouse, allows you to then query the data and create dashboards. So as a developer, you could put these things together and create your own healthcare solution, but also you don't have to use everything. You can pick and choose. You may just choose Android FHIR SDK, or you may just want to use FHIR Data Pipes. So there's a lot of flexibility in how you configure your system. Here's a note. Here's a note on our collaboration with the World Health Organization. So if you have been to Jose's talk earlier this week, the World Health Organization has this initiative to bring evidence-based care to more by using the SMART guidelines framework. So we work with the World Health Organization to achieve that vision. And it's really exciting to see a lot of our early adopters and partners really using Open Health Stack components to create solutions worldwide. Maybe just 1 minute till this map shows correctly. Is that better? Okay, cool. So we have a very active developer community. We engage with our partners and developers technically very to help them create the solutions. Graham came to one of our developer calls last week, and I hope he enjoyed it. And then finally, speaking of community and our partners, we have published a set of stories on our dev site about our publishers' journey to use Open Health Stack to achieve better healthcare income. Better healthcare outcome, not income. Please go and check out the dev site for more information. And that's it. Thank you.
So that was your short break during the rest of paid advertising. Just kidding. No, so I think one of the amazing things about Alphabet is that there's a ton of really smart people all working on FHIR. And that means that we have a really good knowledge sharing across organization and gain a lot of information. As I said, Verily has filed more bugs than most of our users. And it's amazing because we get to fix those before it happens externally, except for I see Andy in the audience, and I'll give him a shout out for Australia's core. And so I think one of the things that we figured out pretty early on is most of our customers came to us and said, well, I want to use all of y'all. I want either just like Fitbit and cloud or Open Health Stack and G4C or research. And we slowly realized that we can't just take FHIR from over here and FHIR from over there and smush it together. And one of my favorite stories to tell when talking about this problem is a COVID story that I had. So Google back in the day when I was probably had less pull than I do now, moved me to the Midwest, which is already, sorry for the Midwesterns out there, but I went to the Midwest in hope that I could fix a COVID problem that was presented to us. The COVID problem was we have patients that are showing up at our emergency room and ending up at the ICU within 8 hours. Our reporting is overnight. And so we have no idea our bed utilization, our ventilator utilization, our predictive capabilities, we're kind of operating blind here. They were about to open the Browns Stadium, not that they needed it for any football fans, but the Browns Stadium of beds, thank the non-American for beds in the United States so that they could support more. And they had no idea if this was a worthwhile investment. And they also had a bunch of merger acquisition hospitals were running on different softwares. They had patients that were going home and reporting that they were having adverse events, and that those patients often ended up back in the ER, but they didn't know about it because the patient reporting wasn't going back into their analytics database. And so they said to us, we have a problem. We need you to fix it. You're Google, you fix everything. And they sent me. So I was like, yeah, young, sprightly, eyes wide open. We actually had a really good solution at the time. It's open source. Some folks have used it before. We had an HL7 to FHIR converter. And we said, go to FHIR, it'll solve all your problems. And we brought all of the HL7 traffic to FHIR and then to a relational database in the SQL on FHIR open source standard I talked about earlier, put a dashboard on top of it and said, and they said, this doesn't make any sense. We were like, what? It's perfect. It's in FHIR. And so we went back and looked at it, and it turned out what was actually happening is that every HL7 message was being mapped to a FHIR resource, which was great. But that meant there were like 1,000 patients for a single patient because we weren't merging anything. This also meant that COVID didn't have an ICD code at the time. And so COVID was showing up as CV, CV19, COVID, COVID-19, every which kind of you can imagine. And so they said, we have no idea how to use this data. It's not meaningful to us because it makes no sense. So we had to kind of come to Jesus moment, where what was really happening is if you just do a traditional HL7 to FHIR mapping, we were kind of seeing this, which is, you get John Smith, he shows up. This is great. But if you don't do anything about reconciliation, when John Smith leaves or has an observation, or really the joke is if you breathe on a keyboard at an EHR, it will fire off an HL7 message. So John had a lot of John records. And so we ended up with a lot of Johns, and they didn't know what to do about it because this is a really difficult problem. And so we looked back and we said, all right, let's take it to the drawing board and build something new out of this, because this is actually really good feedback. And this is when we built reconciliation, and I'll talk more about what that means. But what we actually built is we said, it's not enough for John to be converted to FHIR. John needs to know if John was already there. John needs to know if he's new. John needs to know if he's being updated. John needs to know if he's actually being overwritten. In fact, John needs to know when his period starts, when his period end of almost every resource, because observations are a little bit different. But almost all of the resources that John is going to touch are going to need timetables associated with them, are going to need versions associated with them, are going to need a historical count and track of what John did. And that's a very hard problem to solve. But luckily, we've been doing it for 5 years, because I think that I had such a poor experience in the Midwest that someone felt so bad for me that they were like, fine, Viv, we'll solve this thing that you can't stop talking about. So we got reconciliation. What reconciliation does is it says, okay, one HL7 message actually ends up to what we see about 20 to 25 FHIR resources. All of those FHIR resources need to be merged. They need to be merged and versioned. And it might not always be versioned in an overwrite. You might not be, in a clinical status. That's a good example. Clinical status is almost always overwritten. You don't have multiple statuses at once. But you do merge when it's an encounter, and it's the start of an encounter because you got an admit message, and it's the end of an encounter when you got a discharge message. Those are two completely different HL7 types. Those are one encounter resources, and now you have one period start, period end array. And so we built this logic. The problem with doing this logic is almost everybody does it wrong the first time. So everyone's reaction is to say, okay, I got John, and now I'm going to go read the database to see if John exists. Well, unless every single one of your operations is transactional, you're going to get a race condition. It's not okay in healthcare? Race conditions. The idea that I read the database when John was written 1 second ago, but it wasn't indexed yet. And so that index told me that John doesn't exist, but John exists. He was just written a second ago. I actually read it as it was an old read. It was John actually should have returned as a patient that does exist. And so what we found, although our conditional operations by identifiers are transactional, what we found was that it was much easier to do this architecture. This architecture is to say, okay, put everything in a create. Take those creates, sort them by timestamp, and merge them. So we know, okay, John started and John ended with an encounter. I can sort that because if it was out of order, we already have a new issue. And that the ability to be able to say, here's all of the historical information and use configurable for all of the engineers in the room that are sitting here and going, that looks like a black box. You can change it. So it's configurable logic that you can say, I want this resource to operate this way. I'll say allergy conditions is the most common we see this with, where an allergy could have a snapshot, give me all of the allergies at any given time, or just give me the update of an allergies. Those are very different merge logics. One is a overwrite and one is an append. And so these are configurable because we learned early on, developers want what they want. And so we actually built out this architecture. This is now what we call healthcare data engine. It's pretty much the only page on our documentation anymore because people love it. But it's because we solved a really hard problem in FHIR. And that problem was really actually, how do you know in a way that's scalable and can be counted on? I think the kind of non-transactional or the classic, how do we make sure that things are actually reading and writing the way that we think that they're going to read and write? When you're operating at HL7 time, sub-millisecond, you're reading and writing in sub-millisecond. So you have to have a database that's indexing at that level as well. And so I think doing what we think is one of the better practices is how we kind of architected what is now called HDE. The great thing about HDE is that we learned a lot of challenges on the way. The main one was that nothing comes in order. And so the ability for us to write everything and then actually sort it by timestamp is really important because oftentimes we're getting out of order and we're getting it from many different resources and many different streams. CCD and HL7 is the example I gave earlier where you get a bunch of data over here, a bunch of data over there. How do I make sure it's actually merging correctly and in timestamps that will reflect the patient? If I'm getting new information about them 10 years ago, I need to make sure that's actually being reflected accurately. The other one is also really that the data engine and everything about it needed to be configurable because we had hospital A say, we have 50 Z segments. For anyone who ever has tried to deal with HL7 mapping, that's your nightmare. And so we said, that sounds like a you problem. Here's the code. Have fun. And that was actually one of the better decisions we made, where the ability to configure it and not make it a black box, where a user can go and change their mappings, they can change their reconciliation, they don't have to call my support team every time, is an amazing opportunity because now what we're seeing is we can say, all right, we can actually start to build out a library of these things and say, well, other people did it this way. If you need help, if you want support, if you want to go about it a certain way. And so we solved what I consider second, maybe third problem. And what I mean by that is what I call the maturity model of an LHR. The first problem is to be in the same place. You co-locate your data. Cloud, if anyone needed advice there. You have to syntactically harmonize it. FHIR, if anyone needed advice there. You have to semantically harmonize it. Profiles go a long way, but I think, there's still work to be done there. Most people still need a terminology server. Most people still need something on top of just profile advice. But we're still far, for those who was at my AI talk earlier today, from true maturity of an LHR, which is we are automatically enriching their LHR. A good example of this is I have a customer who does, based on the level of transport that they have in their zip code, we know that they're going to go home and they don't have access to public transport. So we are going to see them back in the ER before they ever go to a primary care physician because they have no way to get there. They enrich their FHIR resource with that information to say, hey, keep them a little bit longer, give them a phone number, give them an Uber gift card. There are options for them to stay. And we actually see a much better rate of readmission when you're enriching their record with information from their background and information that might be meaningful for treating those patients. The kind of meta that we're all working towards of, not Facebook, although I did joke that I was going to show up with those goggles since none of the CEOs did, but what we're all working towards is the inference, which is predict something about that patient. And a little bit different than machine curation, but I think that's kind of the ultimate goal, is getting really good at predicting things about the patient and being able to kind of have that insights. And so hopefully I did a good intermediate between boring your socks off with a sales pitch and actually teaching you something today. But if I taught you nothing else, just know it was really freaking hard to reconcile FHIR resources. We have opinions on how to do this. Others have opinions on how to do this. We think it's something that the FHIR community is going to continue to work on. We think it's something that there should be opinions. We've already seen patient merge opinions come about. But I think continuing on the path of understanding more and more FHIR is going to have to be transactional, and it's going to have to be merged together with itself, with historical data, with other data sources, especially as kind of we move towards it as the exchange mechanism of sources of truth. And really the second part is that being able to have and surround yourself, and this is not on the slide, but I'll get sappy for a second because it's almost the last day. Surround yourself by smart people who are working on really hard problems is a huge benefit of working at Alphabet, but also coming to these events, because we get to have these conversations and you get to learn from all the mistakes that we made in the Midwest, and really being able to have so many different places and parts of our organization that think about different parts of the FHIR standard has been really beneficial. But you know, not everyone can be the Google size, and so I think it's really it's also really helpful to have be participating in the community and, you know, have the Zulip conversations. I probably learned more, as much from Zulip, I won't say more, than from Zulip as I had from my Alphabet colleagues. And so I think, you know, surrounding yourself by, we're all kind of solving the same problem, whether or not we like to think about it or not, and engaging in the conversation is how we're all going to be able to get to an answer that is interoperable. And so I will take questions, but I will not take questions alone because I probably can't answer them alone. So if there are two more, they're right there.
So Vivian, maybe I can have the Google people here on stage with me. And I want you all to take a very close look at these three wonderful people. Why? Because all your Q&A will be in Vondelpark and not here. Because we don't have time for a Q&A. Now, the dilemma is, of course, that in Vondelpark, that's the social event. You're not supposed to talk about FHIR. So we'll make one exception, except for, oh, you won't be there?
Just that.
Oh, them. Okay. Oh, don't talk. Okay. What? Oh, this is difficult. So one exception, you can talk about FHIR with Google, but not with Vivian. Vivian is exception, etc. So now we thank you, Google. Thank you for supporting us. Thank you for the wonderful presentation. And now we have something for you before we go to the buses, which is a broodje kroket. I cannot translate broodje kroket, but it's over there. You can, it's a Dutch snack. Buses will leave in 10 minutes. Just hop on a bus. Bus will leave. We'll take you to Vondelpark. Thank you very much.